We take the structure of our world for granted. We have firm, solid ground beneath our feet and a thick, breathable layer of air filling our lungs. Wind the clock back 4.5 billion years, and you'll find a complete void. No Earth, no planets, no sun. The entire solar system started out as the solar nebula. It was a massive, freezing, entirely disorganized expanse of loose cosmic material drifting through space. Which presents a physical paradox. How exactly do you get from a shapeless, freezing ghost cloud of loose gas to a dense, layered rock capable of holding an ocean? This is the core accretion model. It is a process driven entirely by gravity, where dispersed, tiny particles are relentlessly drawn toward a central point until they form a single solid mass. Over 4.5 billion years, the simple laws of physics sorted this chaotic matter by density, organizing the solar system into the world we know. The process began when that massive solar nebula started to collapse in on itself under the overwhelming, crushing force of its own gravity. This intense gravitational collapse triggered violent spinning and extreme friction, culminating in the sudden ignition of our sun. The immediate aftermath of the sun's birth was incredibly destructive. It blasted powerful, searing solar winds outward into the deep void of space. As this comparison shows, intense solar winds acted as a physical filter, violently sweeping lighter gases entirely away. With lighter elements purged, all that remained in Earth's neighborhood was a stubborn debris field of heavy rock and dense metals. Then came the smash phase. Gravity forced these heavy remaining particles to violently collide and bind together, steadily growing from small space pebbles into massive, dense boulders. Millions of years of these high-speed collisions eventually forced those boulders to merge into a single, massive, molten planetary wrecking ball. Because the early inner solar system was far too harsh for lighter elements to survive the solar winds, Earth was forced to be built out of solid, heavy terrestrial rock. At this stage, the newly formed Earth was a completely liquid, superheated sphere of molten rock and metal drifting through space. Because the entire planet was a swirling liquid, the materials inside weren't locked in place. They were free to physically move and separate based entirely on their own weight. In a cross-section of this liquid sphere, heavy metals like iron plummeted through the magma to the exact center, coalescing into Earth's solid metallic core. Meanwhile, lighter rocky materials naturally floated outward toward the freezing vacuum of space. Exposed to that cold cosmic vacuum, this outer layer of floating rock eventually cooled down and solidified, creating the planetary crust. Which means the solid ground we walk on today is literally just the lighter, less dense rock that managed to float to the surface of a molten metal ocean. We can now pull back to see a completely solid, layered Earth sitting in a solar system that has finally cleared out and calmed down. The young planet now possessed enough concentrated mass to exert a powerful gravitational pull on the space around it. This allowed for a final capture, where Earth drew in the few remaining light gases that were still drifting in the inner solar system. This layout highlights exactly how those captured gases completed the planet. We have the heaviest iron locked at the core, the medium-weight rock forming the crust, and those lightest elements securely trapped against the surface to form our early primitive atmosphere. This sorting creates the foundation for a functional world. The dense metallic core generates a magnetic shield, the rocky crust provides a solid surface, and the light gases provide a sky. We started with a chaotic, freezing cloud of disorganized dust. What emerged was a perfectly organized geological machine. That violent 4.5 billion year process of physical sorting built the only stable conditions in our solar system where the beginning of life was actually possible.